All right, so I think we can go ahead and get started with our last module of the day today. This one is just on kind of a single topic, but it's kind of a more abstract one with the object-oriented stuff. But this will be our last discussion for the day. So just as, again, quick reminder, I know everybody here has already heard this, but this session, like all the other sessions, is being live streamed and recorded to YouTube. And will be available for future viewing moving forward. So, like I said, last thing we're going to talk about today is the idea of object-oriented programming and creating our own classes in Python. This is important to understand because the way that CompuCell runs involves the creation of custom classes. So it's good to have seen kind of how this code structure works when we get into next week. It's also one of the powerful things about modern programming languages is inheritance and object-oriented approaches to programming. So like we've been talking about all day, Python supports the management of many different kinds of data, many different data types, ways of sorting and organizing data. Each of those objects that we've looked at today has had a type, which has an internal data representation. So it can be primitive, like the scalar types we talked about, where an integer is just a number, or it can be a composite, like the lists, with multiple things, each with their own internal index. And then that object has some set of procedures of interaction with the object. So we've looked at strings with our slicing functions, with the split function we just looked at in the last lecture, with turning the thing into a list based on words. And then, with our list.append, we've gone through already a number of different ways of interacting with the various objects we've been working with today. So to kind of encapsulate all that, there's this idea of individual objects being an instance of a type. So what we mean by an instance is one particular example of a larger class of objects. So for example, 1, 2, 3, 4 is an integer value, but more than just being an integer value, it is an instance of the class integer in Python. So you have the class integer that describes what an integer is and how to interact with it. And then you have 1, 2, 3, 4, which is a single, not to keep using the word, but a single instance of the integer class that you can actually manipulate. Similarly, hello is an instance of a string. So string is the abstraction of the data type, and hello is the actual string that you can actually manipulate and use in a programming setting. So again, everything in Python is an object and has a type. We can create new objects of some type. So Python has a lot of built-in object types already, but we can make our own. We can manipulate those objects. And then once we've created them, we can use delete commands to destroy those objects. And Python handles garbage collection for us. There's some programming language that don't, where you have to do your own garbage collection. C is well known for being frustrating in this regard, but Python handles garbage collection for us, so we can delete things without having to worry about reallocating that memory. So again, objects are a data abstraction. They capture some internal representation of information through its data attributes. So each object has some number of attributes that can be modified or used. And then there's an interface for interacting with the object through methods or functions. So like the functions we were defining before, each object type has some number of functions for modifying the object or using the object. And it defines behaviors, but it hides that implementation. So like I was saying, with the module approach to Python, you can create all of the methods for interacting with a type in a separate file and then just import that, so you don't have to constantly look at that code. You can just use the function to do what you needed to do. So for an example, We've been looking at lists today. So if we have a list of 1, 2, 3, 4, it has a type of list. Or rather, it has the type list. But 1, 2, 3, 4 is the instance of list. Lists are represented internally by a linked list of cells. So this is kind of what we were talking about with our indexing, where the index moves from one pointer to the next. And we manipulate lists through indexing, reassigning values, doing split and range commands, concatenation. Talked about all those today. And then the functions that we've talked about using, so we can get the length of the list with the length function. We can find the minimum value and the maximum values. We can delete the list. We can use our append, extend, count, index functions. These are methods of manipulating the objects that are provided by the class that, again, we use on the instance. So to create and use our own types with classes, so there's a distinction between creating a class and using an instance. So creating a class means writing all of the code necessary to describe what an object type is. And then creating an instance is sort of just creating a variable of that type. So again, doing operations on the instances just to kind of keep those two things separated linguistically. The class and the instance is kind of how we define those two structures. These can be structured into hierarchies of objects. So there's a parent class, which is considered the superclass. So this is the kind of top level class that defines attributes that everything underneath it inherits. So you have child classes, which again inherit all the data and behaviors of the parent class. And then you can have further child classes underneath that that continue to inherit, but may have additional properties that are added to it as well. So in this case, person would inherit the traits of animal, and then student would inherit the traits of person, which also includes the traits of animal. I'm just pausing here for a minute to allow people to maybe look at the slide, because sometimes this can be kind of an abstract concept. We'll get into some examples here at the end. So we have a standard process for defining our own types when we want to make a class. So for example, in CompuCell, there's a number of different classes that have been created for managing cell behavior, for example. But we can use the class keyword to define a new type. So this process is sort of similar to how we define functions, except we use class to define the type. And we're going to walk through an example here of creating an XY Cartesian coordinate object and developing some functions surrounding that. So that's what that coordinate is referring to. So let me go ahead and break into my split screen. This in reader view, we can start working through this example. And if this doesn't make sense yet, it will once we're able to actually build this example up. So I'm going to make one last new notebook for today. And again, these will all be made available by the end of the day today in the student materials folder. So if you miss a step or get lost somewhere along the way, the code will be available later for review. So let's go ahead and just start creating our class. So we're going to make class coordinate object, and this just declares to Python that we're going to start creating a class. And we'll need to define attributes. So again, similar to defining functions, we have to indent code the same way to indicate which statements are part of the class definition. This structure allows you to define multiple classes in the same document. And the word object means that a coordinate is a Python object that inherits all of its attributes. So even objects here have to inherit from a core set of properties that are built into the base levels of Python. So this here is where you would define your inheritance relationship. So if we were going to make, say, for example, radial coordinates or polar coordinates, we would maybe say polar coordinate inherits from coordinate in the parentheses. So what are attributes exactly that we need to define? So these are data and procedures that belong to the class, so things that are built in. So there are other objects maybe that make up the class. So in this case, for example, a coordinate is made up of two numbers. You have an X value and a Y value. Think of positioning on a XY grid. And then in addition to the data attributes, you have methods. So these are the things that we use to interact with the object that are built into the class. So in this case, we may want to have a function where we can define how to find the distance between 2 points, how to find the distance from the origin of a point, how to report the values of a coordinate, various things like that. So now that we've specified that we're creating a class, we have to create an instance of the object. So this is what's called whenever you say, so for example, variable name equals something. Say, for example, we're creating an integer that calls this initialization function of the integer class to set up that value. So we need to define and then 2 underscores to indicate that we are overriding the built-in initialization function. Self, X, and Y. Colon, and that. So every object has a built-in initialization function. And what we're doing when we create a class is we're just overriding it to say what we want to happen when we create a class. So we'll go ahead and finish filling this out. Self.y equals Y. So this says what data initializes a coordinate object, the X and the Y. So this is what we need to specify a coordinate object. And then self is a parameter to refer to an instance of the class. So it's going to say it's going to build a coordinate object with the values of X and Y. And then you'll give it 2 parameters, X and Y, and it will assign X and Y as the internal attributes for every coordinate object. So kind of like when you make a list and you need to provide items for the list, what that's doing is initializing a list object, taking in the values you provided as parameters and assigning them to itself. And once we work through how this works in practice, this will start maybe to make a little bit more sense. So that's actually all we need to do to define our coordinate class for now. And then in our same file, to create an instance, we could say C equals coordinate 3, 4 for our XY values. So we've already created our class heading, and we've overridden our initialization function. So now we can create an instance of coordinate as a variable C. We can print that. We can print C.X, and this will actually print the inbuilt data attribute of X that we've given our variable C. So the same way that we use methods like list.append, we can reference internal data attributes if we know what those are called by just calling C or variable.data header. So you can often look into the documentation for various class types to see what individual things are called, and then you can reference those data attributes directly by object.data attribute. Now, if we try to just print our object, you'll notice you'll get this sort of confusing and not useful output. And what this is telling us is that it's using the default print method, which just prints its location in memory. It doesn't actually print anything useful about the class, and we'll talk in a minute about how to override that print function to give us something more useful. But for now, we'll go to c.x, and then we'll just finish filling out this list here. Origin equals coordinate 0, 0. And then we can print origin.x, same way we do that here. And this works also for print c.y. Object ways are suggest doing print their object name. Obviously, we need to replace that with our object. What are we printing here, James? The list of attributes. Or a list of built-in functions, it looks like. All right, so we'll leave that commented for now. Okay, so again, these data attributes are referred to as instance variables. So this x and y is an instance variable. So we can access these directly with normal commands. All right, so a method is a function that works only with a class. So if we define a function within a class, then that method is only applicable to objects of that class type. So again, Python always passes the object as the first argument, as we saw up here. Convention uses self as the name of the first argument in all methods. And the dot operator is used to access an attribute, which is either data attribute or method. So let's go ahead and define a method for this class. So again, we wanted to do our distance calculation method. So we can set this up as self and other. So again, first attribute is self because it passes itself in because you are performing an operation on that object. And then other here refers to some other coordinate object that you want to compare the current one to. So we'll do f difference square. And again, I'm actually going to take these underscores out because I think they're a little bit confusing because the double underscore is used to represent these built-in class functions. You can use a single underscore like you would any other character, but I think the opportunities for accidentally putting in two is too high. So I'm going to change these variable names to f difference squared. And here we want to reference self.x minus other.x times 2, because that's our difference squared in the x direction. So again, this is referencing the built-in data attribute of the current object minus the built-in data attribute of whatever object we're comparing to. So let's do y diff squared. This will be the same thing, just with dot y minus other dot y to the power of 2. And then we will return the difference between those, or sorry, we'll return those two values added together to the 1/2, square root of those. Y diff squared 0.5. So methods behave just like functions here, and they take in parameters, they do operations, and they return values. The only difference is that when it's defined inside of a class, it can only be used with instances of that object type. All right, so to demonstrate how this works, to give some sense to the self.other, we have our coordinate and our origin, and we want the vector difference between the two. So I'm going to put this down here. When we run, well, let me actually keep it up here. So we have our coordinate, we have our origin, and then we can print C, which is our self, current object, or object of interest, C dot distance. And then here is our other, in this case, origin. So this is the other parameter. And then when we run this, you'll see we get the vector distance between these two points. And then here on the right, you can say that this is the same as coordinate dot distance. And you take in C and origin. So you can actually write it this way, the way that it's defined within the class, and just feed in both coordinates as parameters. But when you use this dot notation, C dot distance, it takes C as the argument for self. Abhishek, you have a question?
Yeah, so can you explain one more time what does that initialization function do?
So the initialization function is
Yeah,
essentially what sets up your object when you declare a coordinate. So it's saying it's storing this in the variable. So it's saying I've created an object with X and Y values. And that's being, so you can make a coordinate and use it in something without storing it. If you just set it up, if you just say coordinate 3, 4. So we could do, I believe we can do it this way. Yeah. What the initialization allows you to do is just create the object or the instance of the object class.
okay.
So it's a little bit abstract. But what it's doing in this case is basically just saying we've made a coordinate, we've stored it in memory in the value C. So every class will have this initialization function overwritten to save in its data attributes. Did that answer your question at all?
Yes, thank you.
Yeah. Another question, can self have a default values? That I'm not actually sure. I don't remember what the initial, like there is a default initialization function. But I don't know what it does if we don't override it. I guess we could test. We comment this out, and then we try to run this. Yeah. We end up with no arguments. So I'm not sure exactly what the default arguments for the initialization function are off the top of my head.
Can I just assign values to X and Y on line number 2 as default values?
Um,
So for example, if say by any chance values on line 10 are nonsensical, can I have default values on line number 2?
oh, like values that it will put in if somebody puts in the wrong type of information, is what
That's
you're
right.
asking.
Yes.
I'm not sure off the top of my head. Maybe Jim or James would know. I think in that case, you might need to get into checking with if statements, if that's the concern.
Sure.
You could certainly do it, but you would worry about I mean, if they entered a string so you're expecting a number and then you default to some numeric value, I think you've just hidden the problem.
I was thinking more simpler in that line number 10 rather than 3 comma 4. There's nothing passed in. And so if nothing goes in, does the class type then take on my provided default values on line number 2?
If you call the object and it's expecting two variables and you call it without any variables, you'll get a incorrect number of variables in the call. And I'm not sure, there's presumably a way to trap that and say, in this particular case, you might say, well, X and Y are both 0 or something logical.
Yeah.
Sure, because I'm in the habit of implementing default values in all my functions. So I was wondering if I could carry that over for classes as well.
There's probably a way to do it. Don't know offhand how to do it.
Thanks.
Yeah, we can look into that because that's a good question. But again, like Jim said, sometimes if it's just like, programs that you're writing for yourself and you know how everything works, that's not a big deal. But a lot of times if you're working in a setting where somebody else needs to use the code, if it's not very clearly documented that that's what's happening, and then they put in a value that isn't correct and it goes in as something else and they don't know that, that can be problematic. So that's just something to keep in mind. Because it can make debugging difficult, but for your own purposes, having the default values in a class could be pretty useful. Okay, so here we'll get back to this issue of the nonsensical print statement. So again, if we comment these out, so like we were saying before, if we just try to print our coordinate C, we get again, this just location in memory of where C is sitting in your hard drive, or the pointer to it at least. And this is the default print command. There's a default initialization command, there's a default print command that's inherited from the object class, the object parent class in Python that just points to the memory location. So we need to define our own string method, which is what happens when we call print on the object. Abhishek, what's up?
Yeah, so I have a question. So this thing looks very similar to defining a function itself instead of a class. So what is the benefit of using a class instead of a function?
So functions and classes, although they're similar in structure, are two very different things. So a function is just a set of instructions that gets run when we call the function on a set of parameters. A class allows us to actually create objects within our software, or sorry, within our program, that we can use to store information, and then we can run functions on those objects. So it's not so much a question of cost benefit between the two. They really are two kind of different and interacting things. So every function that you run in Python is being run on an object.
Okay.
So you need both of them in this case. And
Okay. Okay.
if that makes sense. Yeah, so Jim says a function has no memory. So functions are just sets of instructions, but you need objects to store the things that you have done with functions. Otherwise, you can only, run things one at a time, and there's no information being stored.
A great example of a class is almost any modern first-person shooter game or any other kind of competitive game where you have a class that's an individual in the game. But then when the game is running, you have 57 instances of that class, and they're representing 57 different people. Each one of those instances of the class has, a name and an icon and a location and etc. You can't really do that with a function. So class is a way of making kind of a template of data about a thing and then making as many copies of that thing as you want, each with having its own private set of data.
Yeah. And so just to continue with that example in the shooter game, so the data attributes would be like, what weapons and items they have, what skill sets they have, and you can use that inheritance idea of we've created the individual, and then here's different types of that type of, individual object. And then those are all tracking independently what's going on with those objects.
That's a great example, Jim. Can you give an example of a further subclass, like in the example or in the hierarchy that was presented?
Yeah, well,
Which data crosses over into the child?
You might have, in a 2 or 3 dimensional simulated world, you might have a generic object that's just a physical object. But then you might have a subclass of the physical object that can move. So you might have a mountain is one of your objects, but the bigger class doesn't have any concepts about movement. And then the subclass of that physical object would have objects that moved. So the moving objects would have to have additional information, like direction of movement and velocity and momentum and whatever else you need to describe the moving object. But the moving object still has.
Is this within the same context of the game that you were just referring to, where you have
Yeah.
56 or
No,
so?
actually, yeah, in the context of a game. So you might have, like I say, so the non-moving object has a location. The moving object also has location, but the moving object in addition has direction and velocity and momentum and various other things. So you inherit with your moving object, that inherits the idea of a location, definition of a location. But the upper class has no idea about movement. That's all in the lower class.
Oh, I see what you're saying. Okay.
Yeah. So again, in an example of a first-person shooter game, it's like all of the enemy individual object types might have the same general functions for movement. For example, they all move roughly the same way, but they would all inherit the same set of movement methods, but they'll have different equipment, and maybe some of them will have different skills. They'll have different HP levels. So you can use that kind of inheritance hierarchy to define differences among objects of the same type, even though they share some of the same behaviors. They'll have some fine-grained differences the further down the hierarchy you get.
Listed, where would that fall in this type of hierarchical scheme?
Sorry?
Jim mentioned mountains as being within this game example. Where would they be within the hierarchy?
An individual mountain would be a subclass of the higher class of physical object. And then a subclass of physical objects could be another object that includes movement. So you wouldn't necessarily have a subclass called mountain. You might have a superclass and a subclass of non-moving objects. And then you say mountain is an instance of a non-moving object. But then have a subclass of non-moving objects, moving objects. And the addition that you get with the moving object is things related to movement. It's you inherit position, but then you extend that with ideas of movement, velocities and momentums. The good thing is CompuCell does a lot of inheritances in its classes, but you don't need to know that because no one ever writes inheritance in their classes when they're writing CompuCell models. It's too complicated.
Yeah. So I guess one way to make the example even more explicit is you could have a terrain object class. Mountain could be an instance of terrain that would be non-moving, but you could have other types of terrain that are allowed to move. But yeah, so it's, this kind of stuff can get pretty abstract pretty quick. But like Jim was saying, it's like, it's not this understanding exactly how all this works won't be super critical to being able to interface with CompuCell later, but CompuCell does use this process of class creation. So it's good to know, or good to have seen it at least before we move on. And Pedro is mentioning that, yes, we do have a good example in the chat of how inheritance works in CompuCell, and then a swordsman class. So
Yeah, the example I was going to give is like you have the class for the soldier, let's say, in the game, and then you need to create a new one, like an engineer. It has other kinds of methods and parameters. So you inherit all the other already existing parameters and methods from soldier, and then you create more for this specific of the engineer. So I think James' example is exactly the same. So like you have a class which is fighter, and then a swordsman inherits everything from a fighter plus more.
plus a sword.
Yeah.
This actually
Well,
really
that's other methods.
parlays perfectly into a biological example. Like if you have a fighter, it might be an immune cell, and there's a whole bunch of subclasses of immune cells. Terrain
Yeah.
might be a blood vessel if your lymphocytes are traveling through, a blood vessel, and there would be flow. It seems like those all need to be defined differently as players within the system.
Mhm.
And yes, unfortunately, CompuCell doesn't quite implement things that way, and it's kind of coming back and biting the developers in the rear end. As the models get more and more complex, you'd like to have the idea of, but T cell. You have a cell type that's called the T cell, but individual T cells can be quiescent, they can be activated, they can be proliferating, they can be necrotic. And the way CompuCell is set up now, you basically create a new class for each of those, without any ability to have a super cell class, so that you can make one assignment that affects everything of the super cell class. So we don't really have a way of grouping things in a hierarchical way, and for cell types, which is unfortunate. It would make things a lot easier. You'll see later in the course, you start getting into pairwise interactions. And if you have 10 cells, there's 55 pairwise interactions that you have to specify. And that could have been a lot simpler if it was set up as a class hierarchy instead, so you get defined hierarchically. Anyway, in general, though, you won't have subclasses of any class that you create. Excuse me, you won't have a hierarchy in any of the classes you create. That's unlikely that you would do that, I think.
Yeah. So, okay, all good examples. So we'll walk through overriding the print function quickly, and then we'll have an activity, I think. I don't know that there's too much left in this deck. So here, again, getting back, we want to override this print function so that we get something useful out of our print statements. Whenever you use the print function on an object, it calls this default string method, similar to how it calls this default initialization method. So we get to choose what it does, and we want the coordinate to show, and this is cut off at the bottom here, but we want it to show in tag brackets, the X value and the Y value. So we're going to go ahead and just add here. It doesn't really matter what order you add these things in because they will be searched for and found when you call them. And we'll return string self.x. So we cast our passed in value into a string like we've been doing all day. We'll add a comma. And then again, we'll cast our Y value in as a string. And then we'll add our closing bracket. So we've got our special method here. It's all saved. Now when we run print C, you'll see instead of getting our memory location, we get something useful about the class. And then we can also print origin. You'll see it works for both of our instantiated values. And then we can also check, right shift. We can print type C. So in the beginning of the day, we were using the type command to check and see what type of variable is. We use type C. You'll see that it prints out class coordinate, just to show us what type of object this is. And then we can also check to see if we're unsure for some reason, if an object is an instance of something. And I say for some reason, as though it's uncommon, but once you get into larger software writing, it's not unheard of that you would need to check and see what an object actually is. So we can check and see if it's an instance of coordinate. You'll see we get true. So if we were to define x equals 10, just an integer value, we put x in here, we get false. So we can use isInstance to verify that what we're looking at is the type of class that we think it is. So there's some other special operators. We won't go through each of these. But like the print function, you can override these to work with your class. So we've looked at a few of these already. So the length, for example, when we run this on a string, it returns the length of the string. If you need your length to do a certain thing or interpret the data inside the object in a specific way to determine what length means, you can override that length function. So in this case, you could even, so we have our distance function here, but you could even overwrite the length function to just run the same thing as the distance function if you wanted to say. So for each coordinate, the length function will give us the distance from the origin. You can add, subtract, equal. These are some things you can mess around with on your own if you're interested, but there's a number of built-in functions that you can override, and these are all in the Python documentation if you're interested in looking into more. So we do have an exercise here. We can come back around to this maybe in a minute. I want to see the rest of these slides, and then I'm thinking, so we may finish this section a little bit early. I'm wondering, James, if we should open the floor up for questions about installation issues that anybody in here may have for the last 10 minutes or so, just to see if anybody needs help. But we'll decide in a minute. We can come back around to this exercise on objects. Just want to get through the last couple of slides first, showing you a few more things that are good to know before we move on to the rest of the week. So again, object-oriented programming, we've already kind of talked about this with some of our examples, but it allows you to bundle together objects that share common attributes, lets you use abstraction to distinguish between different types of objects, the layers of abstraction, and then to create classes of objects on top of Python's own classes. We have a couple of features for computational modeling and scientific computing, some things that you may want to look into. So some Python packages that get used a lot in these kinds of applications. Random numbers are pretty common in a lot of scientific computing applications. So this is from the library random. So this is what we were talking about earlier with importing. If we want to use these functions, we have to import random. And then we can use, so we can say x equals randint, and then we have a value between 10. Then you'll see when we print 4, every time we run it, we'll get a different value between 0 and 10 at a step of 1, or between 0 and 9, rather. But you do have to import random first. Although I think sometimes in Jupyter, some of these things are automatically imported. You can also use a random seed, so you can create a seed for your random generator that will give you kind of the same random numbers each time if you're trying to test something or you want your simulation to be reproducible. There's a couple other options here. So the random library is worth taking a look into. Time library for grabbing functions related to your system time. There's this well-known fact in the computing world that all computer system time is based off of the epoch, which I think was set somewhere in the early 70s. So all time has been set since that date in the 70s. I don't remember the exact date. But yeah, returns the epoch of your machine, returns the number of seconds since the epoch, and pause the program for X seconds. So this is how you measure differences in time, is how much time has passed since the epoch and when you ran your time collection. The math library is also very useful. So this allows for quick commands for things like square root, sine, cosine, exponents. If you're going to be doing a lot of mathematical modeling in your work, using the math library is recommended so that you don't have to keep typing out a lot of finicky little operators in your equations. Just makes kind of these basic things a little bit easier to use. Similarly with statistics, some functions there that are useful. Again, you'll have to import these packages. Get the mean, median, standard deviation. Then we have a random walk exercise. So Numpy and Scipy are also two libraries that get used a lot in scientific computing. And they offer a wide variety of different sort of analysis procedures that you can use for analyzing data. Numpy has a good bit of calculation-based functionality that it can use. So Numpy, Scipy, math, and random, I would say, are definitely worth reading up on in the documentation if you plan to do any kind of scientific computing in the future. So I think we've got about half an hour left. There are a couple of activities we could do. I think with it being late in the day, we'll do at least one. But before we do that, I wanted to ask how many people here today have installed CompuCell already? And if you haven't, do you need help doing so? Or if you just haven't, tried to install it yet? James, do we have a simple like yes, no poll? We should probably set one of those up if we don't. Sanjay asks why import libraries now and we did not do so all day. And the easy answer is we haven't needed to import anything yet because we've just been working with base Python up until now. But there is additional functionality that's not built into base Python that you have to import from other libraries. So that's kind of why we went over them at the end there.
So do I understand correctly, Hayden, that Jupyter and NanoHub will automatically provide certain libraries, but not others?
Some libraries are included with Jupyter. I'm not entirely sure which ones. I know NumPy is not. Random might be. We can test, actually. If I can still run this. Yeah, so random is already imported by Jupyter, but NumPy is
And
not.
so where would people be able to learn what is imported by default and what is not imported by default? Okay, ask ChatGPT or do a Google search. Fine. I understand.
Yeah. Yeah, I don't know off the top of my head which ones are included, but
And my
it
last
should be.
question,
Sorry, go
and
ahead.
my last question, Hayden, is how many people among your audience do you expect to construct their models purely on online NanoHub, Jupyter, and that sort of thing? And how many do you expect to be developing their models locally in their computers?
So this year, everybody will need to be developing locally. We don't have a remote option for CompuCell
Aha, so
this
then
year.
so then we definitely know which libraries to import and which not to.
Yes, so when you have CompuCell installed, everything you need is already installed on your computer. CompuCell has a built-in text editor where you will do all of your programming. And that text editor will have everything that you need for CompuCell imported already, or at least everything that you'll need for what we're going to do this week. There are some types of models that people want to build where they have to develop extensions to compensate for or to accomplish the specific things they want to do. But for everything we're doing for the workshop next week, we're only using CompuCell's built-in functionality.
Thank you.
So today is kind of a separate lesson using Jupyter. We won't be using Jupyter during the normal workshop. We'll just be using the CompuCell software.
Hayden, you want to walk people through if they've got CompuCell installed? The process of open Twedit, go to demos and load a model, launch.
Yeah, we can do
see
that.
if it runs.
And then, so for those who have CompuCell installed and have already tested it, again, there are a couple of activities in the slides if you'd like to work on something for the next half hour. We've got an exercise on coordinates where you will set up like the coordinate object like we did here has 2 float point values instead of integers this time. And then you'll develop an interface for how to interact with the coordinate objects. So you can add and subtract coordinates, print the representation, which we kind of did already, calculate distance, which we did, and then calculate relative coordinates with respect to another instance. So if you would like to spend a little bit of time implementing that, please feel free. There's also an exercise on implementing a random walk if you would like to give that one a shot. But if you would like to make sure that your CompuCell is working correctly, so I'm in Windows 10 and we will, sorry.
I don't know if you want to keep the exercise slides up on the screen and then use a breakout room to do the CompuCell installs. It's up to you.
Yes, so why don't I do the quick how to test your CompuCell in the main room, and then we can put the activity up and help people in breakout rooms.
Sure. Great.
Because I think it'll be useful for people to see anyway. So I'm in Windows 10. So the easiest way, once you've got CompuCell installed, to open it is just to find it in your programs list. You can just search for CompuCell 3D. So we'll go ahead and start CompuCell 3D. It will put up a terminal. This terminal needs to stay open while you're using CompuCell. If you close it, it will quit CompuCell. This is what's actually running the software. The GUI is running on top of it. It may take a minute the first time you launch it, especially if you've rebooted your computer recently. So just give it a minute to boot up. Yeah, Jim says you should have shortcuts on your desktop unless you told it not to make them. Although I think they're made by default. I think I might have just removed mine in a recent culling.
I don't think the conda install makes the desktop and icons.
Mhm.
If you do the binary install first and then do a conda install on top of that, then you'll have the desktop icons.
Taking a little longer than usual on my end. Sometimes Zoom gets in the way of that first. There we go. All right, so when you first open CompuCell, you'll be given the player interface. So this is the interface that allows you to view the output of your models and make changes on the fly to your model parameters. There's a couple of ways to test if your CompuCell is working properly. One is just to try to open a simulation. So we'll go to File, Open Simulation File. In this Demos folder, which is in your CompuCell directory, which you'll have to remember where you had CompuCell saved. If you're in Windows, the default location is just C/CompuCell 3D. We'll go to Demos, Book Chapter Demos. The one that I usually like to use is the angiogenesis model. And then you'll open the angiogenesis.cc3d file. Sometimes the first simulation you open for the day can take a minute to run. Or rather, sorry, when you open a simulation, it won't start running automatically, but you'll notice that the path at the top changed to your simulation file. You'll hit play. And then it should pop up an output window and run the simulation. Yeah, so we'll do this again tomorrow morning. If this runs okay, chances are your installation is good. But the other way to check, we also need to check Twedit. So this is a model of blood vessel sprouting from an initial lump of cells. And again, we'll go over tomorrow how to actually control all of this, but for now, we'll go ahead and stop. And then to open Twedit, the code editor that I was talking about in response to Sanjay's question a minute ago, we'll go ahead and open up Twedit, which is this icon here with pen and paper next to your zoom functions in the toolbars. Modern resolutions make this very small, but you can also go to File, Start Twedit here. And then again, the first time you open it for the day, sometimes Twedit can take a minute to load. The angiogenesis simulation ended up looking like a dancing man. And then this is the Twedit code editor. And we can do the same thing here. We can open the angiogenesis simulation by going to CC3D project, open CC3D project. And then if we go find our CompuCell directory again, demos, book chapter demos, angiogenesis. You'll see it populates over here. You drop down to see what files it opened, and then you can double click on it to open it in your editor window, which it should be doing any second now. Yes. So if you can run a simulation in Player and you can open the code in Twedit, your installation should be just fine. If you can't do either of those things, then we are available for the next 30 minutes or so to help with that. And we'll put the exercises back up in a minute in case you wanted to take a shot at getting started on those. Jim makes the point you can also open Twedit directly from your CompuCell folder. You can just open into Twedit if all you want to do is look at the code and make some modifications without having to, open Player first and then open Player or open Twedit from Player. You can open in Twedit and then you can actually run simulations from Twedit by right-clicking on the simulation folder and hitting open in Player, and then it will open Player for you if you need it. So you can start in either one and open the other one from whichever one you started. Yeah, so Stephen, you may need to find the book chapter demos folder. So this here is in
At the actual, there's one that was just called demos. I was looking in, I thought it was in the first area there. That was my fault.
yeah, no, it's under book chapter demos.
Cool.
There's a number of different types of demos you can look at, but it's in here. These are the ones that are kind of like our production ready demos to look at that demonstrate some critical components.
You can paste that path into the chat.
That's true, I can. I'll do that now. It might be, depending on where you installed CompuCell, this might be in a different place. But I'll put it in the chat for you anyway. And I believe on Mac, book chapter, I can't send the file path because it's currently in use.
Just click in the address bar and do a copy from there.
Yeah, I think Zoom thinks I'm trying to send a file, but I'm not.
There it
I think it's
goes.
just,
Oh, we got
yeah,
it.
I think it's getting flagged as a trying to send an open file, but I think the path was just confusing it. So anyway, that's a quick rundown of how to check your CompuCell installations. If you can do those two things, should be in good shape for tomorrow. And if not, then please let us know now and we will help you get it sorted out. In the meantime, I can put this back up for anybody who maybe wants to take a look at this. Let me do this in reader mode because it's kind of a pain, full screen. And that covers, besides the remaining exercises, that covers the content that we had planned today for the Python Bootcamp. So again, we appreciate everybody coming out today and sticking it out with us. We know it's a long day. But we think with this information, you should be in pretty good shape to engage in the activities that we have planned this coming week. James has dropped an additional tutorial that we like to recommend to people into the chat. So this is Rosalind's Python Village. You can walk through a couple of activities to kind of test your Python knowledge. Again, you don't need to know a ton of Python for next week. We'll kind of help you through the coding process. But if you would like to participate in the hackathon, we do recommend that people at least give the Rosalind Python Village a try. If you can get through exercises 1 through 5, you're in good shape for the hackathon. If not, that's okay. It doesn't mean you can't participate in the hackathon. It's just good to know that maybe you might want to work with a team where you already have a couple of people who are proficient in programming and you can help with some of the other aspects of the modeling process. So it's not a qualification to participate in the hackathon, but it's a good self-assessment to kind of determine which group you might fit with once we start doing teaming, if you're planning on participating in the hackathon. So I think with that, we'll leave this up for people who maybe want to work in the background, but we have time now for general Q&A for the next. So the session is officially planned to go till 6, and then we usually like to offer 30 minutes of Q&A afterward, depending on what people need. So please feel free to ask us questions now. Again, if you're having issues with installations, please do let us know about that too. I'm going to run to the restroom really quick, but I'll be right back. So Wei Cha, you said you're having trouble visualizing the simulation.
Yes, I tried to open one .cc3D file, and it just saying that in my terminal it just says it is opening simulation file of this angiogenesis.cc3D, but it doesn't show up. But with the edit, it works fine.
Did you
Only
press
this.
so in the player window after you opened it?
Yes, I have the player window.
Did you click the
And
play button
play?
in the upper left?
Yes, I play the I clicked the play button and it started to do the several MC steps, but I don't see any red that you showed us.
Would you be able to share your screen briefly?
Okay, sure.
We can take a quick look.
Okay, great. Thank you.
The window may be collapsed
Oh,
with the sub window.
can you see it?
That's
Okay.
fine. That's correct.
That's
So
correct,
here's-
but I don't see any.
So what you're seeing here is a
Yeah.
2D slice of the 3D simulation in your graphics
Yeah.
window. Up
Yes.
where it says XY 25 and cell field. If you drop down that XY,
Yes. I'm sorry, how can I do that? Okay.
yeah, right there. So go to the 3 dots. For some reason, it's truncated off and then click the
Up.
3 dots.
Okay, 3 dots.
There you go.
Great.
And then you'll have to press play again to make it run. Yeah, I should have mentioned that. Mine
Okay, nice. Now I can see it.
opens to 3D by
Go
default.
up to where it says window.
I'm sorry.
Top pull down menu where it says window. We'll cover all this tomorrow, but where it says window at the top of your screen, window, pull down that menu.
Window.
Top.
Sorry, I don't see it.
All the way at the top. All the way at the top.
All the way to the top. See. Okay, here.
Pull
See.
that down. Pull that down. And where it says tile, select tile.
Yes.
There you
I
Double
see.
click on
Yes.
the left-hand
Now,
side.
if you type the letter R while you're hovering over the screen, no, not there. There, type the letter R. No, put your cursor
Sorry.
over the screen. Put your
Yes.
cursor over the display. Type the letter R.
I don't see
R.
there.
Letter type on your keyboard the letter R. No, don't move your cursor. Leave your cursor
There we
over
go.
the.
There you go.
There we go.
You got it.
Yes. To the center.
And then over on the left-hand side, you have a blue bar. You double click that, or either double click it or right click it. Knowing that solid blue bar in the left-hand column.
Yes.
Yeah, there we go. So we don't see
Yes.
the pop-up windows when you're doing stuff, which is weird.
Oh, okay.
I think she,
Yeah, that's
yeah.
just.
I was visualizing the 2D and I need to
Yep.
switch to 3D. Thank you so much. Great.
Yep,
So
very
you'll
good.
see that exact exercise again tomorrow, but it's good. It's worth seeing it twice, definitely.
Yes.
Familiar with that. It takes a while to get familiar with all the options.
Yeah. Thank you so much. It's very
Thank you,
interesting.
Beth.
Thank you for.
I'm sure a lot of people, if you're having an issue with it, I'm sure a lot of other people are as well.
Yeah, I hope any other people can like solve their problems as the problem as I have. Thank you so much. I will stop sharing.
I have a question. So, what does the number beside the 3D thing do in the play window?
Can you share so you can point to it?
Uh, just give me 1 minute.
Yeah, I think I know. I can share. This one here, there's 3D and then 25 in cell field. Is this
Yeah,
the number you're
what
talking
does
about?
it do?
So
Yeah,
that's the
one.
Z, that's the slice if you're in a 2D view. So you have to switch to a 2D view. And now that number next to it, that's the slice. In this case, it's the Z slice because you're looking at XY.
Oh, okay. Question.
Yeah,
So
so you'll
you-
see as you move the slice back and forth, it shows you different parts of the.
And that's why it's grayed out. When you're in 3D view, it doesn't make any sense to have a slice number.
Yeah, so that number is controlling which slice in the XY plane you're on in the Z direction.
Okay. Oh,
Yeah, it's a
Thank you.
one pixel slice.
Okay. Got it.
All right, any other questions? We are officially at 6 o'clock. So we'll move into our Q&A portion. If you don't have any questions and you're not having any issues with CompuCell, then we look forward to seeing you tomorrow. But we will hang around here either until 6:30 or until nobody else has any questions.